Okay. Yeah, let's start over. All right. Hi, my name is Brett, and I'm here to teach the internet. And basically how it works is, years and years and years ago, we have a computer that connected to a lot of different computers, and these computers interconnecting with that one through the internet, which one in a home, which has me, connected to the internet back this way with the HTTP and the UDP protocol, which communicates through TCP/IP. That's basically how it works. Yes. Yeah, well, it will be. Yeah, you'll get it. So, does everybody get it? We can go home now? All right, let's go back with the rewind button in history to where we go back way, way, way back in the history of understanding how this stuff works. And basically what we have here is we have ARPANET. Okay? And ARPANET was the beginnings back around 1950s or 60s, I think. And what happened was the military said, we need the ability to do a lot of computing and so forth outside of people doing it. So they tried to replace it with people, or computers with people. So they start out with a computer, and then all the other bases started going online one at a time. We have a military base, okay, and then another military base, and then another military base. And they all said, hey, this is kind of neat. Now we can take information from the main computer and we can send it through a phone wire. Back then, the telephone like Cincinnati Bell or Dayton Bell, whatever you got. And they started sending information back and forth from one machine to another. And it was very slow. To send a word "the" might take a second or two. It's pretty slow. Well, what happened over time is the military bases said, hey, we're communicating with the subcontractors like GE who would make the engines. And they said, hey, we want to get in and connected to this network of computers that you have. So they got connected in some fashion physically. So you got the Proctors, PR, GGEs, and all the subcontractors got connected in some fashion to these computers. So now you've got lots and lots and lots of companies out there that are now interconnected one to another, and you no longer have to send all this paper back and forth and this all bind it up and secure it and put a jail in there and a guy with a gun and protecting all the information. They could do it through one machine to another machine to another machine. Well, over time, it's kind of neat. What happens is the big regular folks said, you guys got a really, really neat system out there. We want to connect to that because you have some public information that we'd like to get a hold of without having to get in our trucks and drive the paper from place to place or person to person. So, other companies started getting connected to the ARPANET, which was a network of, and of course the bases, all the individual bases out there. I'll change colors. Let's go to a blue. All the bases, the military bases, were interconnecting one to another as well, not just to the main computer, but a back and forth communication. So the main companies out here said, hey, we want to get connected to your system. And they said, okay, well, you have to pay for the phone lines and you have to put your own computers and stuff, and we'll let you do that. So then all the other companies said, hey, we want lines connected, which then would be like, Cincinnati Bell, and what's a big company you guys know of? Boeing, there you go. Airliners, right. All right, Sherman, right. Well, that didn't work. Let's try orange. What did it say, Boeing? Or Boeing. That's Boeing. Okay, that doesn't work. What happened to all these markers? All right, let's try the ones I brought. Let's do red, blue, green, and this black one. Oops. Okay, what's another company? Sherman. SH, great. Okay, another one? Insurance company, right. Farmers, FAR. We'll abbreviate. And one more.
Gun companies, military, they need guns.
Guns, right. Subcontractors, right. Okay. S&W, whoever they are, right?
Smith and Wesson.
Okay, which would S&W
That falls under.
would be here, right? Okay, right. All right, so now what happened? It grew. And the regular folks, somebody got smart and said, well, shoot, if all you guys are all interconnected on the internet, why can't we sell this open information to regular folk like us that are in a house somewhere? So the days of the internet service provider came into existence. Okay? And they got connected in some fashion to the ARPANET computers. Now, you're probably starting to see how complicated this is really getting. It gets even worse. So the internet service providers, which probably started out with the Cincinnati Bell, in my case, here in Cincinnati, and then you got the Dayton Bell. They got connected. We'll call it Dayton because it's close. And then you have the, Indiana Bells and so forth. So all these phone companies, because we already had this wire across the United States, said, well, we're going to get connected to this. Now we have to figure a way out. We're going to communicate all these computers together. As it keeps growing and growing and growing, the technology gets more complicated because now it's become slower. Because now you have the telephones that people are using and the internet over that same wire. All right.
You're calling that the dial-up days?
Yes, dial-up days. The bulletin boards. You guys remember bulletin boards years ago? Yeah, Edward does. He's way back in those days. And the concept of that was that you had bought a device and hooked it to your computer, and you told the computer to pick this device, pick up the telephone, and dial a number to another number someplace, and that machine on the other end is sitting there listening all the time. And then it would say, oh, okay, you want to connect? Well, what's the username and password? And you would make a connection. It says, okay, you've got the right information. Now I'm going to let you surf or look at the information on my screen so you can gain access to it. And that was very slow. I remember the days where I did that and I'd click a button and I'd sit there for wait, this one would come up and then that one would come up and this would come up and I go, that's just really neat, even though it was really slow. So the ISPs then said, we're going to start selling our services off to the regular customers. So Joe, Fred, Mary said, hey, I want to get connected to that process. What's it going to cost me? I can't remember now. It was about the same cost, maybe $50 or $60, but I think it's about $39 now for your service. So they got connected. So now we got a guy down here at his house. It's kind of getting small here, with a computer connected to a huge, massive access to all of these individual companies, the military bases and GEs and Procter & Gamble's and all these people, the ability to get the information that's free. Now, the bad people, the hackers and the crackers, and there is a difference. One is the intent to harm, and the other one is simply the intent to break in and look at. There's probably a definition someplace on a paper somewhere, but the intent is how they define that. So now we have the World Wide Web is starting to evaluate in the United States to where I, sitting at my home with my cup of coffee, Java, can surf to the ISPs who have websites. Who knows the difference between a website and a web page? Mary?
A website is such as Google, or it's a lot of it does a function.
Okay.
Web page is just your page that comes up.
All right. The real definition is a website has lots and lots of pages that can do lots of different things and link to lots of different other computers. A web page is like one page in a book. When you go to that page, that's all you have. But it can link to other stuff. The site in basically attitude is the entire process and not just one page. And a site can be taking a file from here, from the base computer, a file from here, hooking it up down through the internet, and somehow getting it to this computer over here, to Mary's machine, onto her machine. So that isn't really a website, it's a page or a place to transfer information. Jack?
What website has an address?
Well, we're going to get into that. We're going to get into all that. So does anybody have any concepts or ideas about how this works? Any questions?
It looks very loose, like it's a web
Well,
connected.
okay, I'll go over that now. And I'm going to use this whole board. I want to leave all this up so everybody can get this. Yes, yeah. Okay, the old days of how the physical wires are, let's draw the United States. Come down, and here's Florida, back up, and then here's Canada up here. Gives us our north. North. Every state kind of looks like this. Really good map. copyright this. Okay. It used to be that there used to be a primary wire that would run pretty much across the country this way, and everybody would run their wires to it and connect to it like this. The backbone is what they called that. Nowadays, it looks more like a spider web, for there's wires going every which direction in the United States in all directions. And the reason why it grew to that, well, speed's one of the reasons, but the other thing is, if we come over here into this state and we have one wire running through the state and this wire gets cut, all the people on this back side cannot get to the information in the next United States because that wire's been cut. So they decided to start running multiple lines out of the state from place to place and even connecting from one to the next. That way you have a thing that looks just like a spider web. You have the outer sides and you have the inner connectivity. So if one wire, get off there. So if one wire is cut here, it doesn't matter. This guy is still interconnected this direction and can go around and still get to the other side of the country. I.e., nuclear explosion. You take out a state, well, the people on the back side of the state can still get around through other states to get to the rest of the web. It's pretty neat the way that developed over time. Okay. Now you're probably wondering, well, how does let me get back to my notes here. Let's go through, go ahead, a question. Okay, that's one of my things I'm going to go over in a minute.
The other question I would ask, I guess, if you compared this to a phone system, you have a dedicated links between things. It's not the spider thing.
It is spidered now.
For phones?
Phones, yes. Because the internet, for instance, we're going to use Cincinnati Bell. Cincinnati Bell is a phone company here. The internet and the phone all deal with the same physical wire. So it's all physically connected. Now, when you bring Warner Cable involved, and they said, hey, we don't want to just do cable anymore, we want to get in the internet, they had to connect their cable company to the phone company, so there's an interactivity. And that even gets more complicated nowadays. It was a lot more simpler back in the day. All right, let's start getting into some of the detailed stuff. There's a thing called, I'm going to run out of space, I didn't think I would, public key and private key authentication. When he went over this, my brain melted, and I went, what? Let's assume for a minute, maybe I can do this over the wires here. There's a base computer. This is a perfect example. I'm doing colors. Can everybody see the color differences? Okay? Okay, good. That's working then. Let's say the base computer wants to send a file to a subcontractor that's connected to an internet provider. So we have a subcontractor out here. We'll call him Joe. J-O-E, and we want to move a file. Let's say it's the recipe for Coca-Cola's, how they put all their sugars and all that stuff in there. And we want to move it from here, somehow across the internet, all the way over to where's Joe? All the way over to where Joe is, all the way down through the internet provider, and all the way down into Joe's computer. Okay? But we don't want the rest of the world to see it. One of the things that happens is when you're on a computer on the internet someplace in the United States, and we'll talk about the United States for a minute, he wants to move that from here out to Joe. The way it works, though, is it broadcasts that information to every computer on the internet. How it gets from the base computer to Joe is called an IP address. IP address, which looks something like 90.72.80.1, or let's call it 72. Every computer on the internet, whether it's a cell phone or a physical device, has an IP address, and this is how traffic moves on the internet. How do I know to get information from this computer through the spider web, keeping in mind that there's also interconnectivity this way?
Is that format to say all IP addresses, that many numbers in the IP address?
Yes, correct. Now,
Numbers unique, but the format.
The format is the same, yes. Yes. Now, one of the other things that is happening is with IPv4, which is this way of the numbers, we're running out of numbers on the internet. Okay? So what they've introduced is IPv6. which is the next way of doing it, which changes these numbers. And I think they add another octet or two out here. Maybe it's 75 and 33 or something. But they're changing the numbering system because they're running out, because all these cell phones and all these devices all over the place, it's just too much. Because it's not only the United States, it's worldwide. So, let's get back to how do we move information from here to there so nobody else sees it? Well, here's an example. Let's assume for a minute, let's go to here. Kevin, I'm going to give you my public, this is a public, anybody can have this key. It's like a key to your house. Okay? You have it. Now what you can do is use that key I just gave you and actually do it this way. This is better. I want you to take, this is your key actually. Here's your key. I want you to take that marker, is the information, and put it inside that paper. Okay? Roll it up. Okay? Now, I want you to bend the ends. Okay, now, he just locked that product down with the key I gave him. Nobody can open that product up now that it's locked. I can't, or let me say this. Nobody else can open it even if they have that key I gave him. All right, I want you to send that to me over the internet. Now I have this information. I now can unlock it because I have my private key. The private key is the only key that has the ability to unlock this to look at the information. That's the way it is today, the way they use it. The old days, if I gave him my key, it had the ability to unlock it and lock it. Well, there's a problem with that, because what happens if he accidentally gives the key to our friend over here that's the bad person with a frown? I'm going to get your stuff. That person now has the key to unlock the information. That was the old way. The new way is to only give the person the ability to lock it. And the only way a person can see that information is me, the person that has my private key. That's good. That's a good way of doing it nowadays. That's anything that I want. Well, no. That's only if I want someone to not see it. So, for instance, here's an example. Microsoft Word. I put that Coca-Cola's recipe that only they want to know about in the Word file, and then I use my key to encrypt it. So now I've used my public key to encrypt it, to send it to Joe over here, and now he has that recipe. And Joe has his private key. So let's go it again. If I want to send information to someone else, I have to give them my public key. They encrypt it with the public key, and they send it to me. I then, with my private key, can look at the information. All right? If she wants to send it over to me, and she creates it here, she has to then lock it up with the public key and send it, and I have the private key over here. If I want to create the information here and lock it up, this person over here has to give me their public key. Does that make sense? So each person has a public and a private key. The private key is always given to the person that you want to get information from. So they take the information, they use the public key to encrypt it, and they send it over the internet to me. I have my private key, and I can then look at it.
How does that actually happen?
Well, that's a whole nother teaching.
How do you apply those keys?
You take programs that say, here's my file, I want you to put a key to it. Now, have you ever seen, that's a good question, you ever seen a thing called VeriSign on websites? VeriSign? There's little pictures that says VeriSign on it.
Yeah, with anything that's like a credit card payment.
Credit card payments, banks commonly use this kind of stuff.
Look at somebody's account.
Okay, what they did is bank, let's change colors here. We got a bank over here. Here's our bank. Okay. They went to a company called VeriSign, VeriSign, GN. I'm saying this because it might be kind of hard. The bank went to VeriSign and said, how's our camera? Make sure that stays low. VeriSign and said, I'm a bank. I want you to verify that I'm a bank. Here's all the criteria that I exist. I'm not a false person, I'm not a bad person, and I want you to verify that I'm a good person. So they do their due diligence and they check out that company. Number one, are they at the address that they said they are? Do they have employees? How many employees? All the things that they're supposed to be, they're verified. So what they do then is once they're a verified company, they're an honest person, they're doing business, VeriSign gives them a private and a public key, P-U-B, a public key. So they give them the two keys that they need. So now every time that the bank wants to get information from someone, they give the private key to that person, they encrypt it, and send it back to the bank. The bank now can look at that information because they have their private key. The private key is the only thing that can look at the information.
So these keys are sent over electronically?
Can be. The private key only. Yeah. Okay. The public key is designed so you can put the information in a container that no one can see. Once that public key locks this information, no one can open it.
I'm going too far to ask the question. You're doing a PayPal transaction on Amazon. Does that apply to?
It can. It can. That's different. Encryption is a little bit different than public and private key. Okay, so there's two layers, and that gets too complicated to get into that differences. But the concept is, with the keys, it gives a person the ability on this end to encrypt data and send it through the internet to another person, and that person on the other end can only open it. Doesn't matter whether I get it, the bad person, because I don't have that private key to unlock it. Make sense? Okay, go ahead.
Which one HTTPS uses? Is that encryption?
Just regular encryption. It's not the key authentication. Yeah.
So is your keyword on the other end, like your key, or your password? Like if someone sends you something that's password protected, the password actually opens the encrypted file? Is that your
No. The password protection is something different. It just simply says, before I give this regular file, you need to tell me some information, which happens to be called a password. It's a lot more simpler. Yep. Okay? What's next? A lot of military, I would imagine, and a lot of big companies that are moving information over the regular internet, so they don't want other people to see it.
So it's not the general public?
Correct. Yep. Okay, fiber versus copper. Copper, I've got an example here. This wire is in your home. It's 12.2, I think this 12.2 or 14 is common to all the outlets that we run now. This wire is in this wall, and it has a couple of wires inside of it, and it's made of copper. And electricity goes through the copper wire, and I've been wanting to learn how this works. This is a ground wire, and these are two hots, which is the positive, and the neutral is the white. How on earth does the physics work in copper? And I've had several people tell me several different theories. The one I was taught when I was a kid was, have you guys ever seen, years ago when you're in high school, let's find an empty spot here, and they taught you about atoms, neutrons, protons, and electrons? Okay? Basically you have an atom in the middle, and you have three dots. And you have the neutrons, protons, and electrons. And these actually run in a circular pattern all the way in circles and very fast. Well, back in my day, they said, well, how that works is the next atom that's sitting dead square next to it has the same three guys. And as this one's moving, it actually smacks against the next one. Okay? Yeah, whatever those are. One of those three dots. Okay. So,
free electrons.
right. So when one hits the other, it hits the next one, which hits the next one. It doesn't actually go out of the orbits. It simply rests against the next one. Just as my hand is resting against my hand, the next hand I'd hit move. You guys ever seen the guy with the ball and then you have one ball after the other ball after the other ball after the other ball, and you take this ball and you swing it way up, and you let go, and it comes down and it hits this, but you don't see these balls in the middle moving. You see the one on the end swing up because the energy that's generated. Right. That's the way it was explained to me when I was in high school. This was in 1983. I've had other people say, well, now it's a little bit different. People know different information. Okay. There's a lot of theories out there. My take on it is if any of these things, the neutron, proton, or electron, is given off to the other side, you're changing the properties of what copper is. That's my theory. I don't like the fact that people say, well, as these move around, it actually gives one of these off and smacks the next one, and then that one gives off and smacks the next one, and that's how the electricity moves through the wire.
You don't really change the property of copper. It's got electrons orbiting around the center of the copper atom. And there's like one little extra one out there, and that's the one that gets smacked up. The copper stays the same. It keeps on going into more copper atoms. The bigger, the thicker the wire is, the more copper atoms you got in there.
These are all theories. Here's what gets me. We have created an entire industry of electricity in the buildings, electricity in the computers, and everything, and nobody really understands how electricity moves. We can't open it up and see it move in a wire. It moves too fast, which actually moves at 60 times a second. So every second that you can sit here and count, electricity has moved from this end to this end 60 times, which is crazy amounts.
That's depending on the power line frequency.
Well, there's some other technical things, but I'm talking generals to explain this today. It's pretty interesting how we have people have figured this stuff out over time, but the whole thing is based on we don't really know. We guess, we assume, we come up with models, but nobody can guarantee this is how it works because we can't see it move. Now,
That's not a criteria for things that are in size like atoms and electrons. You're not going to visualize an atom. You're not going to visualize those. They're subparticles.
yeah, it's hard to visualize this stuff. Okay.
You can see it.
Well, right. That's why we don't know.
It can be seen with without using an aid in your eye. There's subparticles.
Yeah.
And I have to be able to.
Okay. Right. It's getting too complicated. I want to keep on the surface. All right. Now, fiber. How fiber works is they take sand and they melt it down and create a fiber, very thin thing, almost like the thin as your hair. And what they do is they introduce light. Here's a fiber optic. They have a machine on this end. It produces light into that glass, basically. And then they have a machine on the other end that sees that light and interprets what it is. And by pulsating it on and off, like say the color green, the way Morse code works, on, off, they can actually send information from one side of the country to the other instantaneously. The other big advantage is fiber optic does not require, let's go down to this end, fiber optic does not require, let's say we're going to run a wire from here all the way across the country. With copper, you have to put machines occasionally in line, and nobody can see that, to boost the current, because over time the current reduces its power, basically, ability to do its job, and you don't get the same thing out on the other end. With fiber, you can string a wire from one of this country to the other, and you don't have to have all these machines in the middle to maintain, hire people, and all that stuff. I was told that it's faster. One of the reasons, again, understand concept, is that, where'd my model go? I wonder if this one's going to work. One of the concept is that I can not only put one color in this end, but I can put multiple colors in this end simultaneously, up to 8. Okay? And I said, okay, that's interesting, because now if I pulsate the green on and off, the black on and off, and the blue on and off at the same time, the machine on the other end is looking at all these colors going on and off at the same time, and it's saying, okay, well, this one over here is a Word file, this one's a cell file, this one's this kind of information, and then it can change that into information that we can see and comprehend. People have also told me that copper moves at the same speeds as fiber. Again, I've talked to several people and sometimes I get different answers and I think, okay, let's just keep concepts and keep that. Jack?
How important it is to the system. It works on copper, it works on fiber. There may be a difference in where they're going with it in terms of replacing lines or maintenance or other issues. But today, the internet has both components.
Yes, it's a mix. It's a mix of copper, it's a mix of aluminum, it's a mix of the Warner cable. Now let me go through the cable and the difference in that one. The cable has...
Your Time Warner cable, is that fiber or is
Well, let me explain that. Cable has in the center of the cable, big old black cable you see, has a typically copper, it can be copper clad or some other things. And what they do is around that wire, they put a plastic sheathing or some sheathing does not produce electricity that can't flow. Around that, they put another layer of a braided mesh of metal that kind of interconnects to each other, kind of like this, around in a circle. So it kind of goes like this all the way around the whole wire, and that stops frequencies from going outside. You guys ever pick up your phone and say, who's on my phone? You can hear like a faint voice of some sort. What's happening is the signals in the air are impacting that physical copper. And that frequency around there is changing how the information in the wire is happening. So the phone on your end is picking up that stuff out of the air and you can hear it. Well, this braided cable on the outside stops that interference into the cable so that doesn't happen. Now, in a house, in your phone, they actually will wrap, let's go with this, they wrap the cable one in the other. So it's kind of like taking instead of putting them one after the other like this, they actually take the wires and they twist the wires. So you got a twisted, that's kind of where comes twisted pair. So one frequency is actually now impacting the other frequency. They're not in line, and that stops that crosstalk from wire to wire and being impacted from the air. Cable got it right when they put that shielding around there with that single wire. Now here's one of the differences between Cincinnati Bell and Warner Cable. Cincinnati Bell takes a wire, you got to remember to visually do this. They take a wire from your house, okay, and they run a wire all the way to the demarcation point, and they take that and run it out fiber. Most are fiber at this point, not all. It's a mix. Warner Cable, what they do is you have a street, okay, and you have several houses, and they run a wire down your street, and everybody connects their wire onto the cable. Now, who can tell me who's going to be faster when everybody gets on the internet at the same time? Assuming you had 20 people over here, and this is the demarcation, the fiber, or the demarcation point. Okay, and here's a house, and this is cable, and this is phone, and there are the same amount of people on both ends, but all of these people get on the internet at the same time, on this end and that end. Who's going to go faster? I think he say that again.
You only have one person who's in the line on the phone.
Okay.
You have multiple there, so they're kind of like stuck in the interview, whatever you want to call it.
All right. There's a thing called bandwidth, and that says that I have only a certain amount of information I can move from point A to point B, and it's X numbers. Let's say I typically get about 330 kilobytes per second at my house. Warner Cable says that this wire can only have a certain number. Let's say it's 720 kilobytes per second. Okay? The thing is, my machine over here can probably run about 550 kilobytes per second. Well, if I can run at 550, and most computers today, he can run at 550, and he can run at 550, Well, that's 1,000, that's 1,500 kilobytes. Can all these people run at the speeds they need to with that speed? No. If I can run at 550 on this end, right, and I have a direct connection to the fiber, assuming that these people allow that go through, I will run at my max speed, assuming everybody's on the internet at the same time. If it's 9:30 in the morning and I want to get on the internet and run at these speeds, can I do that without anybody using the internet? Yes. So, only at certain times is Warner Cable faster, and they won't tell you this because they don't want you to know that. This is stable all the time, but it's slower all the time. For me, I'd rather know exactly how fast is my internet going to be when I sit down and use that. If I want to move a file from place to place, if I want to get stuff, I need to know it normally takes me about 10 minutes to do what I need to do at any time of the day or night.
Who's installing the fiber?
That's up to the internet providers and the Cincinnati Bells of the world, because they're changing it from copper over to fiber. Yes. Warner Cable is doing it, and so is Cincinnati Bell. The day of the word cable will go away. You'll have internet provider. All right?
So, phone company, if you know them, you're in line with how future internet connections to be is going to be consistent.
With the phone company, yes. Well, let me say an exception. From my house to the demarcation point where my physical wire is connected, that speed is set because I'm the only person on that wire. Okay? If I try to access a computer from here and I'm over here, all these internet connectivities determine speed. I can't control that, neither can the phone company. They can control the speed from my house to them. Does that make sense?
Cable doesn't, or it's less, or what I guess what you're saying is that it's connections to data, that depending on what time of day, this speed can be different.
Yes. And I've seen it, and countless people I've gone to work on their computers. I'll try to download something, it'll drop to 54 kilobytes per second in the middle of the afternoon at 2 o'clock. And I'm thinking, everybody's at work. Well, it's because all the businesses are tied into that same connectivity, and it's slowing everything down. And they do this, it's 'cause they monitor the bandwidth, and they look at all the residential housing, and they say most people are going to be at work, so what we're going to do is change our machines, where we're connected to, Warner Cable or Cincinnati Bell, and say all the houses reduce the speeds that they can do and give more speeds to the company, because everybody has changed where they physically are. So if you're at home at 2 o'clock in the afternoon, your speeds, if you notice this, your speeds will be less, depending upon what area of town you're in. If you're next to a big office and complex like this during the week, it'll probably be slower. If you're out toward the country where there's no industry, they may not pull your bandwidth down. It depends upon the internet provider. This? Yes, the ARPANET still exists today. Oh, a little bit of history of this. Go ahead.
Everybody, I mean, I'm just shocked by that. So if I'm a hacker, I'm going after that.
Well, it's not that easy.
But I mean, we're all still connected.
Yes. Okay.
Military, I thought the military went to their own system.
It's still the internet. Now, you can have an internal network, and I probably have way more information than I'm getting into because all these questions. This is good. This is why we're here. The military. Remember back I was talking about the key, the private and public key authentication. It doesn't matter anymore if the military sends information over the internet to everybody, because if they put the key in there, nobody can see it. So you don't have to have dedicated wires from California, okay, all the way, a dedicated wire from here all the way down to Florida with the military, because they can encrypt their data and put keys on it and nobody can see it. So they use the regular phone system or cable system to move information.
How do they separate? Let's just go back to your picture. You got 3 people in houses that are all on the street.
Okay?
And you're one of them, I'm one of them, and somebody else here could be the other person.
Okay, so we got Jack,
How do you
Brett,
separate
and
individual
Fred.
connections?
How do you separate them?
Yeah, I mean, we're all under at the same time, and we're all going to go to MapQuest and get something that individually we want from MapQuest. How, when we go through that system, how does the access and the return stay separate?
Now, what the next thing I'm going to go over, we'll cover that, is how does the information move from one machine to another electronically in the wires, and how does it decipher all this stuff?
It doesn't run over the top.
Correct. How do we keep track of all this stuff? All right, we'll get to that.
If you don't give me that answer, I won't be able to sleep.
Does everybody understand basically how wireless works?
Well, it's just
Okay.
it's a transmitted, air transmitted signal.
Okay, we understand it. Does anyone have any questions about it?
Radio or TV.
Okay. Well, this is commonly a wireless router that you'll get, and it's a Linksys. And nowadays they're getting rid of these antennas, and they're putting the antenna physically in the box itself. You can get these from the provider, the internet provider, Warner Cable or Cincinnati Bell, and they can say, here's your ability to get connected to the internet, and we're also going to give the ability to do it wirelessly. So the signals are sent from your computer through an antenna that's built onto the bridge or the monitor through the air, where it hits these antennas. Remember, we're talking back on the wire, how the air can affect a wire. It's picking that signal up, changing it around, doing what it needs to do, and sending it out through the wire. Now, how that all happens is a whole other lesson altogether. It can overwhelm your brain. There are 4 primary protocols we use: A, B, G, and N. If you guys go to the store and you buy a laptop, it's better to have N. Keep in mind, if you go to office complexes and things, not all places support N. N is the faster. You won't, unless you ask the IT people, what protocols do you use? And nobody's going to know that.
You're talking about it's dedicated
Okay.
to the machine device?
Both sides have to support N. Now, the way to do it is when you buy your laptop, or whatever the device it is, you make sure that it supports A, B, G, and N. So it's supporting all the 4 protocols that are common. So if I go to a place somewhere and they only have B and G, well, my laptop can do B and G. So the laptop typically will know what kind of protocol you use, and it will switch to that protocol and then start to communicate. This is kind of an automatic process.
Is it likened to a foreign language?
Well, yes. So it's a language. It's how to communicate the frequencies and all this other stuff. Yeah.
Brett, most of the computers are the developers, right?
No, mine only does B and G. $1,300 laptop I bought 3 years ago. Didn't know about 3 or 4 years ago. Didn't really get into wireless because I didn't have a laptop. When you get into wireless is when you.
It says it will be supported by wireless, so it will take all those.
Nope.
Not necessarily.
Nope. You have to check out your laptop and make sure that it supports A, B, G, and N. So regardless of where you go, your machine is not the issue. Now, it can be the other machine has got some weird N protocol that's conflicting with the new technology. They've got a 4-year-old router up there, wireless router, and you've got a brand new machine, and they're going, it's G, but I'm not quite sure about this thing. The only thing you can do is when you go to buy it, read it. It tells you right there on it what wireless does it support. Make sure it supports A, B, G, and N, and you're covered. If the place you're connecting to, you can't do anything about them.
Is there an issue of somebody selling them cheaply because they're older stuff?
Absolutely.
And the
Absolutely.
protocol?
And they say, wireless! But they don't tell you it's not going to work in most places because it only has B protocol. So beware, buyer beware in technology. The goal is for them to sell the product to you, not really get you to understand the best product for your needs. I run into this all the time, and it just burns my bridges, but that's why people pay people like me. Okay, let's go to the next thing. We did wireless, Cincinnati Bell, fiber, hard keys, ARPANET. I was going to get into ARPANET a little bit. I forgot the history of that. Oh well. Network. Oh, the network cables that you commonly will use will look like this when you go from your computer to either the box that Cincinnati Bell or Warrant Cable will provide, or, and I always tell people this, I don't know if you guys can see all this, but this is a router. This is kind of like a firewall, okay? So if bad people are trying to get into you from the internet, into your firewall, the firewall says, wait, you don't have the ability to do that. No. Period. It can just simply not respond. Very good product. It costs about 100, 150, maybe 70.
Firewall program or a hardware?
Physical hardware, can be software as well. I suggest getting something like that from Micro Center Mall, which is in Cherryville.
You're talking about the modem being connected.
This is the modem, which actually is an AC to DC converter. It's really not the old modems, but this is the router firewall. It does both. This is, yes. This box here, it's a Linksys, and this is what you want to purchase when you go buy one.
So it provides a wireless service, but it also is a router to protect.
Correct. A router, what routers do is they route information, which all these questions really jump into more information that teaches more information and more information. Whoops. Yeah. All right. Let me recap here. Oh, point was, these wires, when you buy them, they run at different speeds. Cat 5, Cat 5e, and Cat 6. Cat mean category of speed. These inside this wire have 8 individual wires, okay? And they are looking just like this. They are interconnected and wrapped together, so the frequencies, one wire pair next to the other, doesn't affect the other one. That's why they wrap them. The more wraps you have, the higher the speed can go.
Is there a marking to tell you whether it's category?
Yeah, it says right on their cat something,
On the cable?
on the cable itself. It's hard. You get your glasses out and you read this stuff. Cat 6, category 6, it goes up. Lower number, higher number is better. Of course, people never tell you this stuff. They'll just say, here's your network cable. Okay, let's see here. Okay, firewalls. The concept of a firewall, and I just kind of explained that, is as a bad person that comes in through the internet, tries to gain access to your computer, the firewall, you can set it up to do all kinds of things. You can allow certain things to come in and stop certain things. You can have remote administration, which allows me to have a machine here connect to this device somewhere on the internet and control it and set it up and change it around so I can just change things when I need to. Suppose you change your internal network. Let's assume it's your house. We have an internal network that has several computers. Okay? And we have another one down here and another one over here. And these are all computers, okay, in your home. When you put a router involved, they all have a physical wire that goes to the router, okay? And this router establishes where information goes into your home. It's called network address translation, more short NAT. And now we're getting into more of the technical side. Gets back to Jack's question. How do we get the information and how does it move the information from my computer to some other computer? And let's just stick to your home for a minute. Let's put a little house button on here and a square and all this other stuff. Every time a person connects a computer to a router, this router, if it's set up for DHCP, which is dynamic host configuration or something, it gives this computer a number, 192.168.1.100. Normally it starts out at 100. Okay, that's a standard internal IP address to an internal network. Anytime you have more than one computer, it's a network of some sort. Every machine has this number. So the next computer you turn on is going to get 192.168.1.101. Starting to make sense? 192.168.102, 103, and 104, and so forth. Now, Jack's question was, how does this computer know to get the information over to that computer? The IP address is everything. Okay? At home, when I want to move a doc file, a Word file, .doc, from here to there, I have to know this IP address of this machine. Okay? So when I make the connection, I tell my computer I want to make a connection over to this computer, which happens to have a number of 192.168.1.104. It then sends that request out and sends it to all the computers, but this computer is the only one that will listen to it and say, oh, I'm 192.168.1.104, and it receives the information and displays it on your screen or whatever you're trying to do with it.
Can you bring that in?
Yes.
I want to send an email.
Yes.
4 other people.
Uh-huh.
And I've got this data, I've got the information about the event.
Mm-hmm.
People, you need that address.
Right. Okay.
All I'm doing is putting in rec.virtual.
Let's do that for a minute. Let's assume that I have an email here on this machine and I want to send it to Jack, and it's at my house. Well, Jack, how do I know to send it to Jack? Jack says, my email address is jack.radishmala.com, whatever it is. Okay? What's your email?
Jack Shimala.
Okay.
At msn.com.
Jack, what?
Shimala,
sh@msn.com. Okay.
at msn.com.
Right. Okay. So now I know where on the internet he is. He's at MSN. The computers that MSN hold, that's where he exists. Okay, hang on a second. Hang on a minute. Let me go through this. Now, what I do then is in my email program, I tell it I want to go to jackshamala@msn.com. We're going to get into something that this is the time to get into this. Let's go over here. Here's how the typical addressing works. There are 1 or 2 root computers, and let's stick to the United States for right now. There's a connection over here that goes down to your computer. Here's your laptop. Anytime you say, I want a website, let's say Google, all right, this computer does not know where Google is. Even though I have the name, it's google.com, I don't know where this is. So the first thing your computer does is goes through a checklist and checks my computer. Is a place on your computer. Second place is I think it's a DNS lookup, I think, that says there's another list of IP addresses. Well, I don't know what the name is, but is there a number associated with that? And then there's a third one, which I forgot what it is. But if it goes through this checking point on your machine and doesn't see it, it sends that request right on up to the root computer, somewhere in the United States, and says, I want to know where google.com is in the United States. Where is it? All right. The root computer responds back and says, the IP address is 90.22.4.8.13. See how we're always getting back to this number? This is an internal IP address. This would be more like an external IP address.
I know I'm stopping. When you send something, you look at that address bar. Is that when you see the processing?
HTTPS?
No. The email program does this specifically. Okay? So, here's another something that years ago people were doing, bad guys. There is let's draw it like this. There's a guy sitting out here, and we're going to give him a face with some nice, funny, bad guy. And what he wants to do is somehow get you to give him some of your real information, like your username and password to PNC Bank. So what he says is, I'm going to watch any request coming from your IP address, because remember, this computer has its own IP address, and it's internal. It's 192.something.something. Because your internet provider, we'll put the internet provider here, when you turned on your computer, the internet provider gave you an IP address. No. You can pay to make it stay the same, and that's why they changed it to make you pay for it. They're getting better now, not changing it. They're realizing that people aren't paying for it, so why should we change it? And that's how I run my server at home, is my IP stays the same now, and I don't worry about paying for it. I used to pay for it, so it wouldn't change. Go ahead.
You're saying pay for it's what would change?
Yeah, they used to rotate it. Every time you turn off the modem, or you turn your computer and turn it back on again, they would assign a brand new IP address, pretty consistently. Nowadays, doesn't matter what you do. They'll leave it the same, because they realize people aren't wanting to pay for it.
And it's that feature that allows a lot of the controversy that's being created now with tracking, right? If that keyword address were changing?
That's as long as they can find out what your IP address is, they can try to attack you.
Yeah, but that's what I'm saying, is it used to change.
Right.
Prevented long-term monitoring of the movement.
Yes, because if I said I found out that John lives over at 2218 flip-flop lane and I found out what his IP address was, I could go home and set it up and say, hey, I want to watch every piece of information from that IP address. And you can set up a computer to do this. So if I didn't like Mary for some reason, and I said, okay, I need to know what address she lives at, and then I'm going to find out her IP address. Now I can start watching her IP address. And as you do things, I can start recording that into a database and watch everything that she does, every site she goes to and everything that she does, and then start finding out a little bit about what Mary does, if I was a bad person.
So is it better to have a grant to generate the IP address every time?
Well, in the days when people did not install routers, firewalls, and they took their computer and they took that wire and stuck it right into that connection, Windows specifically, Windows had a whole lot of holes in it. Bad guys knew how to exactly come right into your machine, get into your files, look at your files, copy your files, and put it on their machine, and you didn't know they were doing that. Nowadays, Cincinnati Bell and Warner Cable are starting to become firewalls. They're stopping the bad people from doing this because they block the port inputs. Well, that's bad for people like me that want to do remote administration on Mary's computer because I want to help her through the internet without driving all the way across town and that expense. Well, there are programs called Gitso that when you run the program on that machine on her end, it takes the display that she's looking at and sends it from her machine through port 80 all the way over to my computer across town. Port 80 is always open across the internet. That's how all these websites are moving. So now I can give her support because she said, Brett, here's my display, help me. So then I can take my mouse and run her computer from my house. Right, without even having to worry about the firewalls and all that stuff that she has on her end. There's always a way to get around something. Somebody comes up with one thing, somebody creates another one. So it's a constant battle between bad and good fighting, and the world is like this. So that's why all this technology is changing all the time, because bad people say, oh, there's a hole over here. Let's exploit that for a short period of time. Somebody says, okay, we got to fix this, and so forth and so on. All right, so back to this again. I don't know if you guys remember back in the day when you started, hey, you might have a man-in-the-middle attack. Remember that? You ever seen those? Oh, yeah. What happens when you say, I want google.com, and you put the request out on the internet, you broadcast it, he can watch that. Everybody gets this request. What normally happens is when you request that information from the root computer, the root computer goes and looks at the .net, N-E-T, or the .com, or the .whatever. And it goes to these computers and says, where has Google registered itself and what is its IP address? Then what happens is the root computer responds back to you and tells you, google.com is at 90.22.4.813. That's an example of IP, that's not real. And you go, okay, great. So this computer then goes out to the internet, wherever the internet is, goes way over to Google, says, Google, give me your website, google.com. It says, okay. It responds back, and it displays the website on your computer. The site, not just the one page. Well, what happens is, as you put this request out, it takes 1 second or 2 seconds or 6 seconds for this process to go through to find the information and get it back to you. If he can respond back sooner than the root computer does, let's say it takes 4 seconds for this guy, and it takes this guy 2 seconds to respond back, this computer gets a response from the bad guy, and the bad guy says, well, google.com is really at 22.14.8.3.55, which happens to be his IP address. Okay? Mary's getting this, I can tell. So then, what he does, this computer says, oh great, I want to go to this IP address and get the page from bad guy. Well, bad guy says, great, we're going to make PNC website just the same as PNC, and it's going to look just the same way as PNC, and you're going to think it's PNC's bank, or website. So what do? you put in your username and your password, and you give it to Frowny Guy. Okay? So now he knows that you requested PNC, and he has your username and your password. So what can he do now? He can go take your money, assuming PNC allows bank transfers from one bank account to another bank account. They are now. They're becoming more that way.
You pay your payments from your checking account.
Right. Yeah.
In fact, they encourage all that electronic transfer.
Well, yeah, that's right. They're encouraging it, and there's a reason why they're encouraging all this stuff, but that's a whole discussion altogether. The point is, this is one concept of method of tricking you into giving information to people that shouldn't be having your information. So, initially, a real good internet website that comes on board that says, I am now something.com, that something.com, first thing it should do, it registers itself with the root computer so the root computer knows where it is. Okay? So when that request goes up to the root computer, it knows it immediately. And then these machines are getting a lot faster to get this information back to you guys. It's getting better. Can that still happen? Absolutely.
How do you keep that guy out?
Well, that's a whole other class. Well, no, speed's not relevant. Speed isn't relevant. They can still do this regardless of speed coming in out of your machine.
PNC have their database.
Right. All right. Here's back to Jack's original question, sort of. We've kind of gone over a lot. Here's a thing called a packet. Okay? Let's say for a minute I'm at home, and we'll put our little house here, and here's my computer, my laptop. And I want to send an email from here over to Mary. Okay? Every single thing that you send from your computer to another person is broken up into a thing called a packet of information, which has 3 pieces to it. One is, what's this? Right. One is the IP address. 2, where are we going to go to Mary? Where is she? Which actually it's by a name. And there's computers out there that resolve names to IP addresses. So you have an IP address 192, or that's an internal, 70.30.12.2.6. something. The information, which might be a Word document, or an attachment, resume, or a letter, whatever that information is in that email, is put in the middle of the packet. On the back end of the packet is error correcting information. And that's a really complicated thing that I did not understand, and we didn't... What's that?
It's on the back end.
Error correcting information.
Error correcting.
Yeah. It takes mathematics to determine if 1 or 2 or 3 bits of information is lost, it can rebuild it, so the whole packet is complete. If it loses any more than a certain percentage, that packet gets dropped, and it has to be resent. So Mary's computer says, wait a minute, I don't get this because some of this isn't right. This computer comes back to this machine and said, resend that packet, which might be a couple pixels on a picture.
How many bytes are usually in the packet of information, actual information?
Changes. Changes. Based on how much information this is.
How many bytes?
It changes.
Oh, it changes.
Yeah. Because if this Word is 4 pages long for this packet, and the next packet, the next packet, the next packet, the next packet, until that Word file is complete, each one of these packets is going to be a different size.
The answer to my question about people sending things through the same wire because there's different packets that go through the wire.
It's not the different wires. Now we get into how do we route information. All right, let's get back over to here again. This is why I wanted to do this. There's no way I could do a PowerPoint explain all this. Yeah. Well, see, first off, you get this and that. This router goes over that router. HTTP. All right.
Just one quick we end this in about 5 minutes.
Okay. We'll come back. Boy, I got a lot more I was going to go over. I thought I was going to run out of information. Okay. Yeah, this is more than I thought. It's one thing to get in your head and go, well, I'll just explain this and this and this, and I got it in my head and everything's good. Let's do something real quick. Let's do a little bit of a... Well, we're going to take a break here in a minute. We'll chat. Here is my computer. Okay? And, oh, duh. I wanted to do some little kind of examples of some of this so you guys can see the reality of, if someone could get it, yeah, I appreciate it. Okay, here's my computer. And what we're going to do is make a, hey, we're in the dark. Where are my cheaters? Okay. This little program you're seeing called NX is a program that allows me to connect this computer through the internet to some computer on the internet somewhere. And let's think United States for right now, okay? So the login is that, the password is that, and I called it at home. You can call it whatever you want. Doesn't matter. What this is going to let me do, oh, you do have to put passwords in. Hello. Connecting, connected, good. It just communicated. What? Okay. Okay. It may not allow me to type. Shoot. Is that working?
You must be over the ocean somewhere.
Maybe you're looking at the blue sky.
Take a break and then.
There we go. It's not letting me shoot. It's disconnecting when I try to use it. Okay. Well, anyway, I was going to do this, and it's not letting me do it. Basically, what happens is the NX software. I set the machine up on the other end to require a username and a password. Once I give that computer that, it will take the display that's out there that I would look at if I was sitting there, and it sends it through port 80, through the internet, back over to here, to the IP address that this has. And it's going through the router that he has here in the building, all the way down to this machine. And what it then does, it displays that as you can see it. Oh, here we go, it connected. You see how it says NX right here at the top?
Yeah.
Right at personal, blah, blah, blah. This screen, okay, is the computer at home, or an office, or a shed someplace. Doesn't have, it's just a computer on the internet. So now what I can do is, and didn't set it up to where I can run that machine in this. See, that's the only thing with PowerPoint stuff is it disconnects one and allows the other one. He has the same problem. I can, as you see, it looks the same as if I was sitting there. I can take my mouse and I can run that computer and that other place just as if I was sitting there. So the concept is I can then make the same connection from this computer in the office to another computer someplace, make a connection, and then do bad things from that third computer. Make sense? So it gives you a bit of an idea of some of the concepts out there the bad people are doing over the internet that most people have no clue about. So when I say it's important to worry about security, yes, it's important to worry about security. There's a lot of things that people don't know, and it'll bake your noodle. Anyway, I guess we'll take a break now. Is there any quick questions anybody has? Okay, well, let's take a break, come back about 5 or 8, 10 minutes, and we'll continue with me or Joy. Hey, I'm going to open up the packet.